Hello everyone and welcome to class of elastic load balancing. Today in this class we are going to discuss about ELB, which is elastic load balancing concept. So let's discuss about this, that it is a web service and it distributes application traffic across various EC2 instances in multiple availability zones. So to ensure, that means why it is required, to ensure consistency, we require to balance the request load across more than one server. So we have a load balancer, which is basically a mechanism which automatically distributes traffic across multiple EC2 instances. Elastic load balancing service allows you to distribute traffic in one or more availability zones, and you can have high availability in your applications. As we have written that it is used to increase the fault tolerance of user application. It supports routing and load balancing of HTTP, HTTPS, TCP, SSL, which is secure socket layer, to Amazon EC2 traffic. So there are two type of load balancers. We have application load balancer and classic load balancer. So that means load balancer serves as a single point of contact for clients. User can add or remove instances from load balancer as their need changes. Users can also configure health check whenever they require to monitor the health check of the registered instances. It can also offload the work of encryption and decryption to the load balancer so that their instances may focus on their main work. So we have several types of load balancers. Why? For handling different connections, including internet facing, internal facing, and load balancer that supports encrypted connections. Suppose we are having internet facing load balancers. So these balancers, it take requests from clients over the internet and distributes them over the EC2 instances. This is internet based or internet facing load balancers. We have internal load balancer. In multi-tier application, it is useful to load balance between the tiers of application. So internet facing load balancer, it receives and balances external traffic to Amazon EC2. We have HTTP load balancers. It creates load balance that uses SSL transport or TLS, which is Transport Layer Security Protocol, for encrypted connections. So as per our requirement, we can choose the appropriate load balancing. So basically we are having application load balancers and classic load balancers. Now what is there in the application load balancer? With application load balancer, we register the instances as targets in a target group, and then we route traffic to a target group. Our application load balancer function at the application layer, the seventh layer of OSI model. After the load balancer receives a request, it evaluates the listener rules in priority order to determine whether which rule to apply, and then selects a target from target group for the rule. Whereas classic load balancer, we register instances with load balancer. A load balancer distributes incoming application traffic across various EC2 instances in multiple availability zone. It increases fault tolerance and it also detects unhealthy instances and transfer traffic to only healthy ones. Let's see the difference between the two. So classic load balancer and application. So application load balancer supports HTTP and HTTPS only, whereas classic load balancer support SSL and TCP also. The platform for classic is EC2 classic as well as VPC, whereas application support VPC only. Sticky session load balancer generated. Health check is improved in this and access logs are also improved in this. Now, how can we access elastic load balances? So user can create an access with the help of management console. We can access with command line interface, and we can access with SDKs and query APIs. So as we know that management console is a web interface, we can access ELB through it. In our practical class, we can discuss how to access it also. In command line interface, it provides commands for broad set of services. It's supported on Windows, Mac, Linux, etc. SDKs, language specific APIs we require. It manages the connection detail like signatures, handling request, error handlings. We have query API. It provides low level API actions. It provides direct way to access ELV. Now, elastic load balancing works with these services so that availability and scalability could be increased. So, what are the services? We have Amazon EC2, Amazon ECS, Route 53, CloudWatch, and autoscaling. Amazon EC2, Elastic Compute Cloud. It provides virtual servers so that it run user applications in a cloud. We can configure load balancer and route traffic to the EC2 instances. ECS, Container Service. It enables user to run, stop, and manage Docker containers on a clusters. Route 53, it provides reliable and cost-effective way so that we can view to view website by translating your domain names to IP addresses. Here AWS assign URL, that is to load balancer. Now CloudWatch, it enables user to monitor the load balancer and take actions as needed. We can track CPU usage, read and writes, and we can determine whether additional instances are required or not. We have a feature of autoscaling. So if user has enabled autoscaling with this, these are automatically registered with load balancer that are terminated by autoscaling or automatically deregistered from the load balancer. So let's discuss about how it works. Basically, a load balancer accepts incoming traffic from the clients, and then it has to route traffic to the registered EC2 instances across multiple availability zones. Then load balancer, after distributing, it checks the health check of the registered instances and routes traffic to only the healthy one instances. When it detects the unhealthy, it stops running or routing traffic to that instance. Load balancer resumes its routing traffic to that, detects a healthy one, and reroutes the traffic. We can add listeners to accept the incoming traffic. Now, what is a listener? Every load balancer must have one or more listeners configured. It is a process that checks the connection request. Every listener is configured with a protocol and a port. It supports HTTP, HTTPS, TCP, SSL. So why we require SSL? Because it is used to encrypt confidential data over insecure networks such as internet. Elastic, as we know that it supports classic load balancer and application load balancer. In classic, we register the instances to the load balancer, whereas in application we have to register in a target instances as a target which to be specified in a target group. So this is about elastic load balancing that we had discussed in today's class. Thank you so much.